All right, guys. So this PowerPoint's going to go over the scientific method. This is something that you guys should have been introduced to in your junior high years or previous years in high school. So let's knock this out real quick. To be real quick, PowerPoint. So let's get started. All right, perfect. So this is the scientific method. Typically, it's used to approach any problems and be able to solve them in a systematic manner. Essentially, we do this every day, whether it be approaching an obstacle in our lives and trying to figure out what approach that we could use to be able to overcome it. So we really utilize the scientific method on a day-to-day basis. The steps in the scientific method are there's an observation, there is a hypothesis, there is an experiment, an analysis, and a conclusion. Sorry, guys, it's early morning. So these are the 5 steps to the scientific method. So remember these, something that you'll need to know later on this week. With observations, typically it's when a scientist or someone, it doesn't have to be a scientist in general, notices something in our world. So an observation is exactly that. You're just noticing something. And either would it be through your sense of smell, your sense of sight, your sense of touch. All of these are ways that you're able to notice something in our world. An example that they give is you try to turn on a flashlight, but you notice it does not work. The light's not coming on. So that's an observation. You notice that the light does not come on through your sense of sight. So let's keep going. So a hypothesis is where you start suggesting solutions. You guys probably worked with if-then statements, so we'll be doing that for the hypothesis of the scientific method this week. It's a suggestion again to the problem that's at hand. You must be able to test it, so the hypothesis must be kind of like a experiment run, an experiment runnable or an experiment worthy question where we could test it. Sorry, that came out really weird. And also the hypothesis typically predicts an outcome, so it kind of gives how what the outcome could really have. Let's see. So let's keep going. So that's the hypothesis of the scientific method. So the experiment. So this is typically the procedure where we test our hypothesis. So again, like I mentioned, we have to have an hypothesis where we're able to conduct tests on. So a good or valid experiment will only have one variable. So we'll talk about variables shortly in this PowerPoint. A variable is something that we're able to change or we're able to alter to be able to manipulate our experiment or be able to help us identify if our hypothesis is good or not. So a variable is what is being used in the experiment that is being tested. So an experimenter normally changes one factor and observes or measures what happens. So in our lab for this week, we'll be dealing with slime. And with the slime, there's a lot of components. There's glue, there's borax solution or the detergent booster, on water. And those are 3 variables that we can change. But in order for an experiment to be valid, we only could change one of those at a time. So that's why you always hear about scientists conducting many experiments. And that's because there's typically at least 3 to 4 variables in their research. So this is a good rule of thumb that in every experiment, we're only changing one variable or one factor. Yeah, you guys get the point. So there's 2 different types of variables. There's the variable that is dependent and independent. So the factor that is changed is known as the independent variable because someone that's independent is relying on somebody. So that's why the factor is being changed. It's dependent on your decision. So that's why it's an independent variable. And the factor that is measured or observed is called the dependent variable. So if we're getting some type of analysis and we're measuring something, that's the dependent variable. We'll go over this a little bit more in class because I know it can be a little confusing. So if you have any questions, please stop this video and ask me some questions. I'll be in class. So some controlled variables. So typically, scientists keep other factors constant so that they will not affect the outcome. So, like I mentioned, typically scientists or even us in day-to-day lives, we don't change everything in our lives. Typically, we keep one part of our day consistent, and then we change other things. So that thing that we do not change throughout the day is considered a constant, a controlled variable. And same thing with like the slime activity that we're going to be doing. The say that we want to keep the amount of glue consistent throughout the experiments, so that will be the controlled variable. So yeah, that's pretty much that. And after we conduct any tests, we always have to make sure that we compile data. So it tells the story of the experiment and of our research. It's the results of the experiment, may be quantitative, which is numbers, or qualitative, which where you're describing it in words and sentences. It must be organized. It must have charts, tables, or graphs, any visual representation of your storytelling of your research. I will go over that a little bit more later. And then the analysis. To analysis. Okay. So your data is the physical representation of like what you did. So it's telling somebody like this is what I got. Whereas an analysis is your description of it. So it's the storytelling. It could be the lab report. It could be a simple write up. That's typically what you want to accomplish is a lab report at the end of every lab. But we'll go over that a little bit this week. And finally, your conclusion. Typically, it's whether you answered your hypothesis or not. And this is the reason why scientific method is always going through steps. If you do not answer your hypothesis, you start back up to your hypothesis forming stage, and you try to figure out another hypothesis to test and conduct another experiment, controlled variables and independent variables, and figure out if you're able to reach a conclusion that your hypothesis answers your question. And that is it, you guys. So go ahead, make sure you guys are taking Cornell notes. Remember questions and summary. And please keep this, if you have your chemistry journal, keep it in your journal. If not, keep it on a piece of paper for right now. Make sure to hold on to it. And I'll check it sometime next week or the following. Okay, guys? Thank you.